So again, in the notebook, again, like it's numbered, so that's like the order. So one page is the title page, then 2 pages for models, and then 1 page for vocabulary.
But like 2 pages is one side and do not.
The best way to do it is like this way for the models. It's the best way to do it, so you can have the notebook open, looking at 2 pages. You don't do it that way; it's not the end of the world.
So we put unit 4.
For now, yeah. I mean, again, it just says right there, guys. Like, just read the instructions. You can read those. I'm sure of it. I have no doubt. That's why they're there. That's it. All right, we're gonna move on to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. All right, so success. The goal today, you're gonna make observations, wonderings, and a model. That's gonna be something you're not too sure about, so that's gonna be okay. Because it's okay to be wrong. And now tour. It's okay to be wrong. It's okay to make guesses. We're going to have expectations about your work, but being right is not one of them. At least for now.
Can I go to others? Because they need to give me the lavado.
You're welcome. Good catch, man. And success is this, actually doing the work.
I do right.
Right? So doing the work, and I've wrote this down. So when I look at notebooks or when I'm walking around and looking at what you're doing, it's a success. If you don't do this, then you're not successful. It doesn't count. It's an incomplete. It's 2 academic responsibility strikes. It lowers your academic responsibility grade. Doing the work and doing your job, that's your job. All right, I'm going to pass out something called a knowledge sheet. So a knowledge sheet is basically what we call prerequisite knowledge. So it's things that we should or not should. But if we know them, it's going to help us to learn. Okay? This is your sheet. You need to keep track of it. You need to know where it is. Some people have been gluing it into their notebook. You do not have to do that. But whenever I ask us to take out our knowledge sheet, you need to have it. Okay, so you are responsible for this. So as I hand it out to you, take a look at it, read through it, and we're going to talk about it a little bit.
When I tell you
I mean, do you have glue or anything? No? I would just fold it up and keep it in my notebook. Yeah, so take a look at it, look at some of the terms, read through it. This should start to illuminate for you what it is we're going to be working on this unit and learning about. Those of you playing at home and missing class, here we go. All right, so what are some things that we noticed about this Mateo? What's blurry? Images are blurry? I mean, it seems fine. Are they perfect? No. Am I going to color? Am I going to put 95 things in color? No. So do the best we can. What's something that you noticed, Mateo?
What?
What's something that you noticed about the knowledge sheet? It has different things. Let's be a little bit more specific. What's one specific thing I have?
Like, there's like a lot of fossils and like.
So there's this term fossils. Okay, we have fossils twice. Great. Amalia, what's something that you noticed? There's what?
They're like things from the past.
From the past. Okay, cool. And another thing. What do you notice?
What?
Okay, something about the bedrock. Okay, cool.
That's
What else?
like, there's something about these rocks.
Okay, rocks. All right, so what our next unit of study is going to be about is this idea. I think you studied spheres in 5th grade? Biosphere, hydrosphere,
Yes.
all that stuff. What was the other two? What were the other two? Geosphere. What was the geosphere? What was the geosphere? Do you remember? Anybody remember what the
Everything
geosphere was?
outside.
Thomas? Sphere of the rocks, and all the non-living stuff on Earth, the geosphere. So geo means Earth, G-E-O. So this type of science is called geology. Okay, so we are going to be geologists. We're going to be focused on the Earth, how it makes changes, the history of the Earth. As Amalia, did you point out the history? Somebody pointed out the history. Okay, so we're going to be talking about that. This is Mount Everest. Mount Everest is located like Nepal, Tibet, around there in Asia. It is the highest point in the world. It's not the largest mountain. The largest mountain, I believe, is in Hawaii, but most of it is under the ocean. So it starts at the bottom. So if you measure it from the bottom to the top, that one's taller, but this is the tallest point on Earth. Okay, people do climb it. It is very difficult, but more people do it now. Some people have done it without like oxygen masks and stuff. Just like Mui Tesla. All right, so this is a mountain. Mountains are enormous. We're on a mountain right now.
I walked up there.
Okay. You walked up to Mount Everest. I don't believe it. All right, so we're gonna think about a few things about Mount Everest. One fast movement in seconds and minutes. One about slow movement when we're thinking about millions and billions of years, and then something else. So back in 2015, a massive earthquake hit Nepal. All right, it was about a 7.8. So if you know anything about earthquakes, that size was really powerful.
What is the biggest one?
Ever around 9, they think, historically. The whole mountain moved 3 centimeters. And you're like, 3 centimeters is only like that much. But in the entire mountain, like an earthquake shifted an entire mountain 3 centimeters to the southwest. Okay? So what I want you to do in your notebook right now is one thing that you notice. It could just be about the poster, that's fine. And one thing that you're wondering about. What's up? It moved it, 3 centimeters to the southwest. One thing you notice, one thing you're wondering.
Oh, we read it on this?
In your notebook.
Oh, in the 4.1.
Bless you. Now, one thing I want to point out that I forgot to point out to other classes, so you're in special class. This is below the ground.
So it's like
Okay, so this is the surface, right? The mountain, but underneath that's under the ground. So there's plenty of space underneath the ground. So as we're drawing models and stuff today, that's and throughout this unit. This is one of the things we're going to be thinking about is how do we show things underground as well. How long do you think a billion seconds was? How long ago? If you had to guess, a billion
1 year.
seconds. 1 year.
3 years.
3 years.
I don't know, 30 years.
30 years. You
And
ready?
4.
4 years.
52
55
years.
years?
No, I think it's 600 years.
600 years. Tomas was almost exactly right.
What?
You're almost exactly right.
How many?
31.7. So a billion seconds ago, I just graduated high school, which is nuts. I was just about to go to college. I was 18.
Very nuts.
A billion seconds ago. In a billion seconds, I'm going to be 81 years old. And I'll still be younger than my father. My father's 84, so that's weird. You all will be 41, almost my age, in a billion seconds. Okay, a billion is a lot, is what I'm trying to get to. Okay, so the Earth has been around 4 billion years. Okay, and so when we think about mountains growing, and this is the slow movement, a mountain, this one, grows about 3 centimeters, 0.3, so 3/10 of a centimeter a year. It grows about. Okay? And it moves 4 centimeters. And it grows 0.3, and it moves 4, and it grows 0.3, and it moves 4 every single year, all the time. And when you think of a year, that's not much, but in a million years, it's a lot. In a billion years, that's a lot.
We have this planet has not been habitated in a billion years, or has it?
Habitated by what? Mountains?
Yeah, no, like animals, like living.
Oh, but I'm not talking about. This is geology, not biology. So we're talking about mountains.
Okay.
We're talking about landforms. We're talking about the Earth and how it moves. What's up? Everything that's not alive. So every year, like clockwork. So what's something that you notice, and what's something that you're wondering about the slow movement of Earth? And even that is a great wondering, like how long living things have been on Earth.
Why did it grow so much?
Great wondering, write it down. Okay, now, if we look at the second item on the list on the knowledge sheet. Eloise, what is the second item on the knowledge sheet? Eloise. The second thing, what is the second, huh? What kind of fossil? A marine one. And what does that mean, Nicoletta? What does a marine fossil mean?
That's your
Nicoletta. The ocean was there. So it says this place was once underwater. So at some point, right, you find on the ground, you see, if you've ever been to Villa Leyva, they have ocean type fossils there because that part of Colombia used to be under the ocean.
But that is because the ocean like shrink or because
It's a great question. That's one thing we might find out during this year. So these are marine fossils. They were found. They were found on Mount Everest. So I'm going to say this one more time. These fossils were discovered on Mount Everest, on the mountain.
So the mountain go in the sea.
So what do you notice and what do you wonder about the idea? What do you notice and what do you wonder? Write down your wondering, write down your noticing about. Oh, yeah. Soup. Okay, now on the next slide, we're not going to do what it says because not everyone is here. Okay, so some of us are going to write down our wondering about the fast movement of the earth, which is the earthquake. Some of us are going to write down our wondering about the slow movement of the earth, which is the growing every year. And some of us are going to write down our wondering about the fossils found on Mount Everest. Okay? You all are writing down your wondering on the post-it note about the fast movement of the Earth, okay, the earthquake. You all are writing down your wondering about the slow movement of the Earth, the slow of the every year. There's one thing I wanted to point out that somebody pointed out. What direction does it move?
Right.
Northeast.
What?
So northeast, it's moving northeast.
Why?
What direction did it move in the earthquake?
Southwest.
Southwest, so that's completely opposite. So northeast and southwest are completely opposite. Just something to point out. Let's see, east is what, over here? Right? Where's the sun?
East is over there.
I was like, way over there. West?
East.
East, west?
So we retrasar one east, west. So right now we are
South.
east or in the west.
South, north. Yeah, so right now it's moving this way, and then in the earthquake it moved up.
So they
And again, it moved 3 centimeters in that minute, but in a year it moves 4 centimeters. So again, that's much more violent. And then the last 2 rows over here, you're going to write up your wondering about the fossils. Okay, does that make sense? So do that now on the post-it note.
what we got of those first.
You're going to write down your wondering about the fossils.
I mean,
These fossils.
and me.
Huh?
I'm wondering.
Fast movement. The fast movement. The earthquake. The fast movement.
Yeah.
What is your wondering? Not the thinking. The wondering. Like, what is your question?
What? Why did it move southwest?
It continually moves northeast, and then during the earthquake, it moves southwest.
Mr. Like right now we are in the east or in the west.
What a wonderful question. I will tell you it depends.
We are facing
Do you know what it depends on?
what it depends.
It depends on the point that you're referencing. So we are to the west of Venezuela, right? We are to the east of the Pacific Ocean. We are to the, north and west of Bogota? Is that right? Northwest of Bogota?
Northeast.
Do you see what I'm saying? It all depends. It all depends what your point of reference is. So you can't really say. That's why, like, we call someplace the Middle East. That doesn't make any sense because east of what?
And what are we facing?
What are you? You're facing east. I'm facing west. That's a good question. Okay, at this point, we're going to read our questions out loud. And we're going to listen to each other. After that, you will put your post-it note on the driving questions poster on the back, and we'll go out to break. Okay, but once everybody gets through their questions. These are the questions that we will try and answer during this unit. Okay, this is what's driving our unit. That's why it's called a driving questions board. Okay, so I look at these, think about them, and then go according to plan. So Greg, start us off. What's your question? Gregorio, what's your question?
My question is why the earthquake to the Everest?
Great question. Mimic.
What? Also, my question is like if there is like a massive like earthquake, the mountain shrink into the ground.
Ooh, great question. Tommy.
Why the mountains grow?
Okay, that was more of a slow moving one. You were supposed to write one about the fast movement, but that's okay. But when you put it back, over there, put it for slow movement. Did you look at the numbers and stuff? Don't worry about it.
What number?
It doesn't matter. So when you put your post in the back, put it under the word slow, not fast, okay? Do you see in the back the poster?
Yes.
Okay. Martina, your question.
How mountain change like
So rapidly. Great question. Pedro.
My question was, how does the tall mountain Everest get so tall if it was so small? And also, why does the mountain move northeast, but when
The earthquake goes the opposite way?
moved it southwest?
Great questions. Nicoletta.
My question is if you can stop the mountain like
Can you stop a mountain from moving? Great question. Or great question. Yeah, great question. Molly.
Why does it take so long to grow, and why does it move to the opposite side as it would in America?
Super cool. Mariana.
If a mountain grows big because it grows every year, then the tallest mountain is also the oldest.
Ah, what a great wondering. Martin.
How does a fossil get to the Mount Everest? And the Mount Everest was like the Mount Everest was in the water.
Super. Really good. Amelia.
How the fossils form.
Super. Eloisa.
Where was like the mountain was covered in water.
Ah, okay. Wonderful question.
That's why,
The same one? Cool. Mateo.
like, I think that the earth was like a mountain that wasn't like so tall, and it was in the ocean, and then it grew through the years.
So if that's what you're wondering that did the mountain start in the ocean? Great, great wondering. The one question I know we won't answer is how do fossils form? I don't think we'll get into that. It's because it's going to be more about the movement of the Earth, but we'll think about it. Okay, we'll see. Before we leave, I want you to think about the last unit.
What?
I want you to think about before we go to break. I want you to think about the last unit. I want you to think about the last summative you took and all that information that you learned. How many teaching days do you think I used to teach you all that information? How many? 10 or 20?
2 months.
2 months?
Oh no, 3
days?
months.
3 months?
But like
9 days.
9 days.
9.
like almost.
That's it.
My
Yeah.
question was like,
Well, you said 10 or 20. But 10, you should have stuck. You should have stuck with your gut.
say 10 to 20. No, I was like gonna like preguntar if were like whole days or like every hour counts or
No, like the time we spend together, right? So remember, every we do 3 classes, then an assessment, 3 classes, then an assessment, 3 classes, assessment. So right, we took 3 assessments and then the final, and we had a project. So you only had 9 classes, and you learned all that stuff. Like, that's pretty amazing, right?
Since the starting of the
Pretty-
year, we've only had 9 classes.
No, for the unit.
Oh, I was
For
like,
the unit. So each unit, like we're gonna spend. This doesn't count because this is like intro provocation stuff. Try to get you interested. But with me actually teaching you stuff, it's 9 days. So the amount of stuff you're able to learn in 9 days is incredible, right? You should be very proud of that. That is what kills us about interruptions. Right? When people interrupt, like it's brutal because we only have 9 days. If I have to stop because you're doing stuff, but you're really interrupting, like people could learn more. Like if that's what we can do in 9 days with interruptions, imagine what we could do without. Okay, so think about that. As we go to break, please put your post-it note under the correct word. Thank you.
Inka, llame Inka.
O sea, sí, pero no, yo lo compré.
Man, it's tough having to do all that work.
¿Necesitas un lapicero? Mira, ahí tienes todo. ¿Ah?
Tengo tres pescarías.
Ah, sí, yo tengo
Okay, so the next thing is this. We do not need to be correct. All right, that's nothing that we need to be. But we do want to try. We want to try and draw a model, okay, of both the fast and the slow movement of Earth. Again, you do not need to be right. right? For you to be right now, that would be like, wow, that's pretty incredible. Okay, so don't worry about that. What we're going to worry about is the following. Every single model that we create this unit, we are going to focus on three things. Arrows. Right? We need arrows that show what is moving, okay, and why. What is causing it? So there's cause and effect. What is causing the mountain to move? Okay. Number two, we need labels. We need labels on our arrows. We need labels on our object. Okay, we need those labels to explain what people are looking at. And we need a cross section. What cross section is like I said on that one poster. You are in your model, you have the surface of the earth, and you have what's going on underneath. Okay. So today, again, it's not about being right. It's just about thinking and trying to get something down without any idea of what might be happening. And that's fine. All right? That's the idea today, is just taking a risk. Okay? So in those 2 pages I asked you to keep for models, okay, you're going to make one of the models on the top half of the page and the other model on the bottom.
In the first one.
Yep, on that one on the left.
So like we take half of the page.
Half the page, half the page. So the first one is this idea of fast, right? Yeah, fast. This has happened in seconds and minutes. This movement, right? The earthquake. Okay, how can you model that? What might that look like? Again, focusing on arrows, labels, and that cross section, top and bottom. And then the second one is the slow movement, millions, billions of years. How can you model it? Again, this is just trying. This is not being right. Okay. At the end, I'm going to randomly choose people to put their model underneath the camera, and we're going to look and see, do you have arrows, do you have labels, do you have a cross section? So that's it. None of you are right or not.
What is a cross
There are
section
some,
mean?
cross section means the surface and the below the surface. These are some words you could use and think about. You don't have to. I'm not going to define them for you, but they're here. Stress, slip, uplift, erosion, rock layers, below surface movement. They're here. You do not have to use them. They're just point them out. So we have a few minutes to work on that, about 5, and then we'll go from there. Yeah, I'll randomly call people to bring their models up.
The slow moving is like how do
It's 0.3 centimeters a year, 4 centimeters movement.
No, but
The slow.
like the fast is here. The slow is here.
Sorry, yeah, faster.
Is how much the earth shaking. Pues mitad.
What think about? How could you do that? How could you do that?
We don't need more anymore.
Here you're talking about. It didn't have to be it was just like page 1, page 2. Because they might have you do other stuff over. Bless you.
Like this is like are we gonna learn away about it?
What do you think?
Alright.
Do you think this is what we're going to learn about?
Like drawing a movie. Yes.
So like where is like for where is Marine for here?
What's that?
Where is Marine?
You guess? I'm not counting. That's what we're going to learn. Just guess. Who cares?
But it needs to be with Mountain Everest.
Yeah.
Oh. that you're doing it.
Just for the people who are here.
Why?
Because if I use my normal thing, it'll waste a lot of time because it'll fit people who aren't here. And I don't know if you know anything about me, but I hate wasting time.
Yeah, I know. You say you don't like when people.
A few more minutes? About 2 more minutes, then we'll start sharing.
Everyone needs to.
We'll see, we're gonna spend 5 minutes sharing, so that could be 5 people. Right, one problem, but that's it. The problem is six. What's that? We officially launched the unit tomorrow, like actual teaching, and so the next thing.
So they say what that topic.
This is like the launch, this is what's called a provocation, just trying to get you interested in the unit. And then tomorrow we'll start the real teaching. And then go from there. That's part of the first of the 9 days. Why would I disrespect you and not teach you because people are gone? Doesn't make any sense to me. They have to do all the work. They have to watch all the videos and do all the work at home. You sacrifice for it, right?
How horrible.
And it's not horrible. They have a great experience. They have to
I do
sacrifice.
not like to do things at home.
Cool. That's life. Life is balance. Life is about finding balance and figuring out how to do as much as you can. Another minute, and we're gonna go. Another minute. Another minute. If you only have one, that's all right. We're only gonna look at arrows, labels, and if you did a crosscut. That's it. We're gonna look to see if you have labels on everything that you need to have labels on. They don't need to be correct. They just need to have labels that explain. We need to have arrows that show movement or causes, and then we need cross section. 55, right? That's what time we get out of here.
And then the low movement.
All right. So again, we're not judging the quality of the model about does it explain what the phenomenon is. That's not what we're doing. When the model gets put under the camera, we're looking at, do the arrows show movement and cause? Okay. What's that? You need to keep it. Notebook's fine. You need to have it was 0.3 centimeters a year. Labels that explain, and then trying to do the cross section. The cross section is going to be the hardest part. All right, so the first volunteer is Eloisa. 20, I promise. Look, 20. I'm not lying. 20. Go. Bring them all up, please. So again, arrows, labels, cross section. That's all we're looking at.
Like this.
All right. So do we show movement arrows? Everybody.
Yes.
Check. Do we have a cause arrow? Kind of. Right? This is the cause arrow, right? Really good. I was like, oh, I was a line until I saw an arrow. We have a cause arrow. Do we have labels that explain?
Yes.
Yeah, and do we have a cross section?
What is a cross section?
This is the layers of the earth, right? So she has the bottom and the top. Excellent. Really good. Thank you.
And the other one too.
I know it's fine. Next up, Tomas. 21. Tomas, you both happen to be sitting right next to me. That's why it's confusing. I can see it. You said you didn't know what was happening. That was great.
Like this.
Cool. Do we have arrows that show movement?
Yeah,
What's this? What's this one?
What?
Destroy? Is that what that is?
Yeah.
But you're gonna need your notebooks there.
That's true.
Do we have an arrow that shows cause? Like what caused it?
Is in the bottom.
This stuff here? Okay, earthquake. So remember what Eloisa, she had that arrow at the top? And then maybe for earthquake, you would have an arrow on both things. So remember it's a line, and so we put an arrow. And you have labels, Cool. And then is this the bottom? Is this below the mountain? Like the under the ground?
Yeah.
Okay. It kind of looks like it. One of the things that Eloisa did was like say layers or label that part, so that would make it more. We'll see. 15. Great.
How many days
We're gonna go 2 more minutes.
It's like
Whatever.
you know all that quiz stuff.
And in every single class, all 95 kids.
You know.
Yeah.
What number
17.
How do you remember everything?
I don't know. I remember numbers from last year. That's weird. From what class they were in. I don't know. All right. Do we have arrows to show movement?
Yes.
Yeah.
Do we have arrows to show cause? What's this down here? Is this your cause?
Yeah, no, that first one was
No, but like this thing down here. Is that like time lapse or? Okay. So this is kind of cause. This is like a time frame. Cool. Does it show cause though? So we don't have arrows to show cause. But we have arrows to show movement. Do we have labels? So what could be a good label here? Sarah? Or like 0.3 centimeters, or 30 centimeters, something. Right? That would be a good label. And then did you show underground? No. Okay, so some things. That's all. Well done. Lassie. Amelia. Amelia. Alright, do we have arrows that show movement? Do we show arrows that show cause? Is this the cause, the erosion?
Yes.
Cool. Do we have labels that explain and everything?
Yes.
And then do we have underground?
Yes.
We do. Great job.
So I
Alright, once everyone's packed up, chairs are pushed in, I'll start.
11. I think of these. So like these from the platform underwater. This is the only thing I remember that it moves. Shakes, right?
Okay.
So I think it broke and
Right.
no one broke this in
Okay.
and this moved one.
Mr. Like, where do I put the paper with all the things?
Keep it in your notebook.
But I don't have glue.
You can fold it and put it in there and then wait for another day.